Hey there! The Earth and its atmosphere, while essential at protecting us humans from all kinds of things, from radiation to meteors, also has an impact on rockets that need to get out of the confines of Earth's gravity. In this video, we're going to explore the effect of atmospheric drag on rockets and how it relates to the commonly used term in rocket launch, Max-Q. Let's get spacey. Let's start off by taking a look at this picture of a Falcon 9 rocket on its way to space. At this point in its flight, it is well up into the sky and has broken the sound barrier, which is the speed at which sound travels. We can see this haze around the top part of the rocket, which is the first thing that comes in contact with the air. And this is visual proof that the air in the atmosphere does indeed have some degree of influence on a rocket. Now, let's look at this clip from a SpaceX livestream of a similar Falcon 9 launch. At about T plus 70 seconds into the rocket's flight, we can hear this call out called Max-Q.
Max-Q.
Let's take a look at what this call means, and it's all got to do with dynamic pressure. The actual pressure that a vehicle feels as it flies through the atmosphere is dependent on the velocity of the rocket, as well as the thickness of the atmosphere that you're flying through, which is of course dependent on a rocket's altitude, with a decrease in thickness as you go higher up. This can be simplified into this equation. One thing to note here is that the velocity dependence is as the square of the velocity, while that of the air density is only to the first power. So you multiply all these together and you get the dynamic pressure on a vehicle at any given time. Now initially, as the rocket lifts off, the velocity is increasing faster than the air density is decreasing. This creates a net positive dynamic pressure on the rocket. And so, the total dynamic pressure continues to rise until a maximum point, after which you're so high up in the atmosphere that the density of the air is decreasing at such a rapid rate that the velocity cannot compensate for it, leading to a decrease in dynamic pressure. What I just explained can be shown in a diagram just like this, whereas the speed, which is denoted by the Mach number, increases, the dynamic pressure also increases up till a certain point before it falls off. Now this maximum point right here is what is called Max-Q, which stands for maximum dynamic pressure, and is where the aerodynamic stress on the vehicle is at its greatest. Well, that's it for this video. If you enjoyed it, please consider liking and subscribing, and leave a comment down below for any questions or suggestions. I'll see you in a bit, and until then, stay spacey.